Welcome back, chemistry students. I had a phone call and my phone decided to automatically shut off. So we're going to try this again, part 2. Last time I talked to you guys, we were discussing the acid dissociation constant of a weak acid. Now we can calculate it. So I'm going to show you that. Some of you guys might not care for it because guess what it involves again? It involves an ice table. So we're going to set it up, so you get your initial change in equilibrium. I'm going to show you this. But some of you guys that really enjoyed the ice tables, hey, guess what? We get to do ice tables again. Alright, so it says we're going to calculate a dissociation constant based on this problem. So it says a 0.1 molar solution of ethanoic acid is only partially ionized from measurements of the pH of the solution. H plus is determined to be 1.34 times 10 to the negative 3. What is the acid dissociation constant of ethanoic acid? Here's what I like to do when I'm setting up these problems. I use the general form for the acid. I don't need to know the formulas because really the only thing I'm concerned about is these three things: the original acid strength, how much H plus I have, and how much of the anion I have. So I don't have to write down the technical acid there. And then what I do is I set up my ice table. I go like this. So initial, change, equilibrium. Here we got these right here. Then I read through the problem and I try to think about it. It says a 0.1 molar solution of ethanoic acid. That's got to be the original strength because that's what we made it to be. So 0.100 is going to be the original strength. Actually, another 0 there. So if it hasn't ionized yet, initially I'm going to have 0 H plus and 0 A minus. I'm off to a good start. This one is going to change by a value of x, while these guys are going up by a value of x. Okay, if I continue to read the problem, it says from measurements of the pH of the solution, H plus is determined to be 1.34 times 10 to the negative 3. What is the acid dissociation constant of ethanoic acid? So what I'm going to do, I don't want to deal with scientific notation because it's to the negative 3, so I'm just going to 1, 2, 3. Alright, so that is going to be the H plus. So down here, the equilibrium is going to be 0.00134. Okay? So that's the H plus. So then the A is also going to be 0.00134. And that actually equals the value of x. So we can plug that into here and get our new value. So we'll take 0.1 minus 0.00134. And I'm going to get 0.09866. Carry all sig figs till the end. That's important. Don't round until the very end of the problem. I have carried every single digit. That'll help you guys out. Okay, so now we're ready to answer the bigger question on the problem, which says, what is the acid dissociation constant of ethanoic acid? Well, we need to know the equilibrium concentrations. Hey, we use the ice table to figure that out. Now it just ends up being like the KEQ, products over reactants. So this one will just be 0.00134 just for the purpose. Running out of room there, I'll put it squared divided by 0.09866. So now I can calculate the Ka of that acid. 0.00134 squared divided by 0.09866. I get a Ka. Now sig figs, I get a Ka. Well, I got 3 here, got 4 here, then round to 3. 1.82 times 10 to the negative 5th. that tells me the strength of that acid. So there it is. There's the Ka. Yes, we had to use an ice table, but it's really not too bad. The biggest thing you got to remember is, all right, so this is the initial, hasn't been allowed to dissociate yet, so 0 and 0. When you measure the pH, that is telling you that, okay, this is what has happened. When it's dissociated, so boom, that number goes there, and then you just figure out the rest. If you get, iPad, I gotta switch this. Okay, I'm back. Yeah, the iPad sometimes just automatically disconnects. I don't know why. Yeah, so here's the ice table. If you can't read, my handwriting, it's right here for you. They set it up. So here it is, 1.82 times 10 to the negative fifth. All right, so let's try another one of these involving an ice table. It says in an exactly 0.1 molar solution of methanoic acid, the H plus is 4.2 times 10 to the negative fifth. Calculate the Ka. So again, I'm going to leave myself more room this time. I'm going to start with the general form for an acid, which just Ha goes to H plus. And then I'm going to set up the ice table. So there's that. I'll go 1, 2, like this. All right, so now we can start to fill in the ice table. It says in an exactly 0.1 molar of the ethanoic acid. That 0.1, that's the strength of the original acid. So that's going to go there. Like the previous problem, it hasn't dissociated yet, so we're going to go 0 and 0. These ones will go down by a value of x. That one's going to go up by a value of x. We found the H plus concentration to be 4.2 times 10 to the negative fifth. So I can take this 4.2, move it over. 1, 2, 3, 4, 5. Such a small number. So 0.000. Another one. 42. 0.000042. We'll take and subtract that from 1, or 0.1. And I get 0.099958. Again, don't round yet. Include all the numbers that you can till the very end. So now we'll calculate the Ka. So the Ka is just products over reactants like we did in chapter 18. 0.00042. I'm going to square that because it's just easier. And then divide that by 0.099958. Okay, so here we go. 0.000042 squared divided by 0.099958. I get a Ka value. Technically, I should use 1 sig fig, but you know what? Let's add a 0 so we can get a little more accurate number. So let's call it 0.10. So then I'll use 2 sig figs with this problem. We're going to go 1.8 times 10 to the negative 8th. Okay, for fun, which acid is stronger? Think about that. We solved 2 problems with the Kas. Which one is stronger, the methanoic acid or the other acid that we just did, the ethanoic? And hopefully your answering is that this one's a little bit stronger, right? The Ka is bigger, so the ethanoic acid will be a little bit stronger than the other one. Let's see here. I think you guys, I'm gonna leave this one on your own. I think I'll leave that out. So there you go. That's how we calculate the Kas.